Hello. We're not going to have time in lab to do a little pre-lab lecture like we've done for the last couple of weeks, just because of how things are going to work out with the cadaver lab students who are teaching with us this week. So I am going to basically do my pre-lab lecture for you now. I want you to treat it just like you're in lab, so copying down drawings and labels and things. If you have any questions about the things that I'm going to draw for you, send me an email, let me know, and I'll try to clarify. Here's the best part. However long it takes me to record this video, right, that'll be like your time spent with me, I will let you out that early on Thursday morning, okay? So please take this seriously. It's important information that it'll be a lot easier for you to learn the structures on the cats and cadavers this week if you actually take the time to watch this and copy things down. And we're already 1 minute in, so you're already getting out at 10:29. I'm going to start by reviewing the branches of the arch of the aorta that we looked at last week in your cat and in the humans, and I am just going to draw the human version today. So here's our heart. Coming off of this heart, we've got an aorta, and the aortic arch has 3 branches in humans. Here we have the right brachiocephalic artery. That artery will rapidly branch to give us a right subclavian that is headed out to the right upper limb, and a right common carotid, which is headed up to the head on the right side. We also have a left common carotid and a left subclavian. So these are the ones that you saw last week. None of this should be too crazy. Now we're going to look at the branches off of the aorta that happen inferior to the diaphragm. So this part of the aorta, remember, is our ascending aorta. Up here we have the arch of the aorta, and then here's our descending aorta. Here's some new words for you. I'm going to draw on the diaphragm here in green. The part of the aorta, the part of the descending aorta specifically that's in the thorax, is called the thoracic aorta. The part of the aorta that is extending inferior to the diaphragm, this is our abdominal aorta. Now we're going to take a closer look at the branches of the abdominal aorta. So the diaphragm is now going to be way at the top of the screen. Here's the abdominal aorta as it descends. I'm going to start with actually the last branches that come off of the abdominal aorta. So it's continuing down, and when it gets to the bottom, it's going to bifurcate. That just means split in two. So this whole thing is the abdominal aorta. And what we have here are 2 arteries called common iliac arteries. In anatomy, when you see the word common, what that means is that that structure is now going to split again in half. So from the common iliac artery on each side, we then get a branching pattern that looks like this. The one that continues is called the external iliac artery. The external iliac artery is going to continue down into the lower limb, and it will get renamed there. These other branches that are headed more medially here, these are our internal iliac arteries. These are going to stay within the pelvis. So the pelvis is the part of the body that's right between the abdomen and the lower limbs. So in humans, it's where things like the rectum, the uterus, and the bladder can be found. The internal iliac arteries stay within the pelvis. The external iliac arteries will exit the pelvis and head over to the lower limb. The next thing I'm going to show you is the difference between a paired and unpaired artery. So a pair is always going to be two things, right? And so as the aorta descends and has these two branches, these common iliac arteries are paired arteries because there's two of them, one on the right and one on the left. There are two more sets of paired arteries that you're going to be learning. The first is hanging out right about up here. These arteries are extending over to kidneys. Those are supposed to be kidneys. They don't look too beautiful. Both of these arteries are called renal arteries. Renal is anything having to do with kidneys. These are arteries going to kidneys, therefore renal arteries. The other paired arteries coming off of the abdominal aorta come off kind of just off the front side of it. They're much smaller than the renal arteries. And they kind of look right now like they're going to nowhere. These arteries are called gonadal arteries. In a female, we would call these ovarian arteries, as they would be traveling down into the pelvis to go to the female ovaries. In male, we call these testicular arteries because they're going to head down out of the abdomen into the scrotum to supply blood to the testes. So if you cannot tell what gender a specimen is, what sex that specimen is, they would be gonadal arteries. If there is any way to tell whether it is male or female, you then give them their appropriate names, either ovarian or testicular. So what you're looking at here are all of the paired branches off of the abdominal aorta. We've got renal arteries on the left and right. We've got gonadal arteries on the left and right. And then we've got the common iliac arteries on the left and on the right. The next thing that we need to look at are unpaired arteries. And so I'm going to draw a new version of this to clean it up. So here's our diaphragm again. Here's our descending aorta. And here are our iliac arteries at the most inferior portion of the aorta. There are 3 unpaired arteries that branch off of the abdominal aorta, and all of these arteries are going to be supplying abdominal contents. First, right inferior to the diaphragm is something called the celiac trunk. I drew it just as a little circle right here because the celiac trunk is a relatively short-lived artery. A trunk, just like a tree trunk, is going to have branches come off of it. A arterial trunk is also going to have branches come off of it. In the case of the celiac trunk, there are going to be 3 arteries that will be branching off of it. One of them is called the hepatic artery. The liver is over here on the right side of the body, and so this hepatic artery is going to be heading over to the right. There are 2 branches of the celiac trunk that head over towards the left side of the body. One of them is called the splenic artery, and I'm drawing it all curly like this because that's what it looks like. So the spleen is over here in this upper left quadrant, kind of hiding behind the stomach usually. And so in order to allow this artery to deal with the stomach expanding and contracting, because the stomach would be sitting like all up in this space right here, but more anterior than the artery, the splenic artery has kind of this pigtail looking appearance. And it is headed over to the spleen. The other branch that's coming off of the celiac trunk and heading towards the left is going to be heading towards the stomach. This is going to be the left gastric artery. Gastric is anything to do with the stomach, and so this artery is headed over to the stomach. So just to recap those guys, the celiac trunk is a branch off of the arch of the aorta just inferior to the diaphragm. The celiac trunk then branches to give us a hepatic artery that heads to the right towards the liver, a splenic artery that's kind of curly and pigtail looking that heads over to the spleen, and a left gastric artery that's headed over to the stomach. The stomach is not drawn in this picture because it was just getting a little messy. The next unpaired artery that we care about sits about 1 finger width inferior to the celiac trunk, so right about here. This artery is called the superior mesenteric artery. I hope the word mesenteric sounds kind of familiar to you, because remember the mesentery that you saw both in the cats and the cadavers, that connective tissue that was uniting all of the intestine together. So if here's our intestine with its little loopiness, we would have this yellow fatty tissue hanging out, connecting this together. Well, we find the superior mesenteric artery traveling within the mesentery to get out to the walls of the intestines. Okay, so that's why it has got mesenteric in its name, because it's traveling within the mesentery. There's one more artery that's not on your structures list, but you'll see it and you'll wonder what it is. Much more inferior, coming off of the anterior surface of the abdominal aorta, this is the inferior mesenteric artery. Just like the superior mesenteric artery, this will be traveling through the mesentery. It just will supply regions of the digestive system that are lower. So inferior mesenteric is going to be providing blood to the large intestine primarily. Superior mesenteric artery will be supplying blood to the small intestine. The last thing that we need to look at is the venous circulation that is corresponding to the arterial circulation within the abdomen. So we've already looked at the formation of the superior vena cava. I'm just going to remind you of this really quick, that if we have our heart here coming from above, coming from superior, this would be our superior vena cava. We have a left and a right brachiocephalic vein that unite to form that superior vena cava. And then in the human, what we see is we've got an internal jugular vein coming down from the head, and we've got a subclavian vein coming over from the upper limb, uniting to form that brachiocephalic vein. So always remember that in veins, blood is coming back towards the heart. And so we've got internal jugular plus subclavian giving us our brachiocephalic. Same thing over here, jugular, subclavian, brachiocephalic. Those two brachiocephalic veins unite to give us your superior vena cava. So that's how we're draining blood from the head and the upper limb back into the heart. We also need to drain blood from the abdomen back into the heart to be recirculated. And so the inferior vena cava, I know you've seen it in cats. I don't think we've looked at it in your cadavers yet. You will have seen that coming up through the diaphragm. So the diaphragm is sitting right about here. We don't see much of the inferior vena cava in the thorax because it comes right through the diaphragm and dumps into the heart, specifically into the right atrium. I'm going to redraw this again, and we're going to look at what this looks like in the abdomen. So just for reference, I'm going to draw the diaphragm at the top of the screen now in green, like it has been. And we've already seen the abdominal aorta within the abdomen, and we've seen its branches. and I'm not going to relabel these because then this would be a total mess. We saw that up in the thorax, the thoracic aorta is shifted to the left of midline. The same thing is going to be true in the abdomen, except now the aorta is going to be a little bit closer to midline. However, it is going to be to the left of the inferior vena cava. So here's our inferior vena cava hanging out. Oops, sorry, I drew that on the right. Nope, sorry. That's right. The aorta is on the left of the inferior vena cava. Sorry, I'm getting left and rights turned around. So it's going to have branches that very much parallel the branches of the artery way down in this area, and we'll get to those eventually. The other things that I want to show you are just like we had renal arteries, we're going to have renal veins. And here I'm drawing veins in blue because these are going to be low oxygen. Just like we had gonadal arteries, that I'll put back on here in red, we're going to have gonadal veins. Here's a big difference though. The right gonadal vein typically drains back into the vena cava. The left gonadal vein typically drains into the left renal vein. And the reason for this is that the vena cava is way over here on the right. In order to get blood from the gonads way down here back into that, it would have to really like cross over everything in the middle of the abdomen. And so instead of doing that, it just comes straight up here into the renal vein, which then drains back to the inferior vena cava. One thing you'll notice is that we had these unpaired branches of artery here. We had our splenic, our celiac trunk, our superior mesenteric artery, and our inferior mesenteric artery. We're going to have veins that are similar to these arteries, except they're not going to drain to the inferior vena cava. All of the veins that are kind of paired up with these unpaired arteries are instead going to go drain to the liver. So here's a liver. Here's what happens. The splenic vein is coming over this way from the spleen. It's going to meet up with the superior mesenteric vein. Those two veins get together. So let's label this quick. Here's splenic. Here's superior mesenteric vein. When those two veins get together, that forms the hepatic portal vein. The whole reason for this is that the blood that's traveling in these veins is coming back from the gut tube, so from the intestines, from the stomach, and this blood contains things that have been absorbed from within the digestive system. The nutrients and potentially toxins or drugs that have been absorbed into that blood need to first go to the liver to be cleaned, okay? So the hepatic portal vein takes blood from the guts to the liver. What happens then is there's a vein called the hepatic vein. This hepatic vein is what will bring this blood into the inferior vena cava. And I'm just going to erase this little piece right here. Okay, so right here I'm showing you the inferior vena cava. Whoops, point. The inferior vena cava. This is the hepatic vein taking blood from the liver that's been cleaned and putting it back into the inferior vena cava. So that is the end of our video pre-lab lecture. It looks like it's taken me about 20 minutes to get through this. So normally we go 8:40 to 10:30. You'll get out at 10:10 on Thursday morning. So make sure you have taken good notes on this, otherwise you will be very confused on Thursday morning because we are going to get right into studying cats and cadavers when you arrive on Thursday. See you then!